Hey guys, these are our notes from Monday about adding and subtracting rational expressions. That's going to go into your digital notebook. You can fill in your table of contents. Slide 12 and 13 is add/subtract rational expressions. I do have the PDF of this located in Google Classroom, but you can just handwrite it on a piece of paper. So today we're going to be doing adding and subtracting rational expressions. You do not have to write down the essential question. It is located on the Google Slides. But basically we want to be able to answer at the end, how do you add or subtract rational expressions? What do you have to have in order to start? Okay, so here's basically what you have to have to do any of your problems. You must have, when adding and subtracting rational expressions, is common denominators. So whether you're adding one or two fractions or three fractions, you have to have common denominators, okay? However many fractions you have, they all have to have the same denominator. Once they have the same denominator, you just keep the denominator the same and add the numerators. So keep the denominator the same. Add numerators. This is usually by combining like terms. Then factor and cancel if possible, which is what we did last week. So we did simplifying rational expressions last week and multiplying and dividing. Then today we're doing adding and subtracting. Okay? All right, so here we're going to talk about how you create common denominators, kind of some steps. So the first thing you want to do is just factor your denominators. And this depends on, if you have monomials, you can make like a factor tree, list them out. If you're doing polynomials, you got to do GCFs or snowflake, whatever it might be. The second thing you're going to do is go ahead and decide which factors each fraction needs to be multiplied by in order to make the denominators the same. So decide what factors each fraction needs to be multiplied by to make the denominators the same. The third thing you want to do then is just, after you've decided, you're going to multiply, and you have to do both the numerators and denominators. Our fourth step, the next thing we're going to do, is distribute and multiply only in the numerators. The denominators you don't actually really have to multiply out. You want to keep them sort of factored. Then you're going to go ahead and keep the denominators the same. And combine like terms in the numerators. The last step would be that factor and cancel if possible. So this is what we're going to take one picture of when we go to do our digital notebook. We are going to also do like the invalid values and everything, but we don't have to, I'm not going to write it down again. Okay, so from your workbook, you guys need to grab your workbook. This should be page 19 in your workbook. And we're going to do all 5 examples, okay? So first example says simplify the rational expression 3/5 plus 2x. The first thing they ask us to do is identify any invalid values. You look at the denominators, and if there's an x, right, then you would, you see what would make 0, right? So you say x cannot be equal to 0 for this one, because if you plugged in just 0 to the second fraction, it would make a 0 denominator. Okay, so then we're going to look at our pieces. It says find a common denominator. So I have 3/5. I'm going to kind of space them out. I have 2/x. So when you look at your denominators, the first one says 5, and the next one says x, right? So the first fraction is basically missing the x, and the second fraction is basically missing the 5. So what you're doing is you're kind of multiplying the first fraction by the second fraction's denominator on the top and the bottom, and then the second fraction gets multiplied by the first fraction's denominator on the top and the bottom. So they are both prime. 5 is prime, x is prime. There was really no factoring to do, so you just kind of multiply, this denominator went over here on these two, and then this denominator 5 went over here on these two. All right, now that we have decided what to multiply by, we actually multiply by them, and we get 3x over 5x plus 10 over 5x. So now my denominators are the same. So when you add them together, you just keep the denominator. That part just stays the same. It doesn't change. And on top, you would combine any like terms. Well, I have 3x plus 10. I can't actually combine anything, so I just rewrite it as 3x plus 10. And then step 4 says check to see if the result can be rewritten as a simpler form. So what you would look for is, can anything be, factored and canceled? Can these cancel? No, because this one is holding hand, so we can't cancel it. What you'd have to do is look for a GCF on the top, but 3 and 10 don't have a GCF, so this is just going to be our final answer, and then we have our invalid value extraneous solution of x can't be 0. All right, let's go to page 20 on the back and do our other 4 examples. So this one says 5 over x plus 1 plus 3. So I kind of write my fractions a little bit bigger than how they normally are, and I always try to factor my denominators. So the first denominator is x plus 1. That can't be factored. There's no GCF or anything that can be factored out. And then I make the 3 into a fraction, so I put 3 over 1, and I kind of just make my fractions a little bit bigger because I'm going to have to multiply by something. So then I look and I see if they have anything in common. So you guys might notice that both of them have a 1, but the x plus 1, they go hand in hand, right? So there's no, I couldn't cancel x plus 1 over 1. I wouldn't be able to cancel those. Those aren't the same factors. So basically you take what the second fraction says is 1 on the bottom. I'm going to multiply the top and the bottom by 1. And then whatever the first fraction goes on the second fraction. So x plus 1 goes on the top and the bottom. So basically I'm taking this denominator and multiplying it on this fraction. And I'm taking this denominator and multiplying it on the other fraction. When I do that, I get on top 5 times 1 is just 5 over x plus 1 times 1 is just x plus 1 still. Plus, and then 3 times x plus 1 would be 3x plus 3 over 1 times x plus 1 is just x plus 1. So now you should have common denominators here, or else you made some sort of mistake with your multiplying. And when I have the same denominator already, I just keep that denominator the same. And then on top, I would combine any like terms. So 5 plus 3x plus 3. So I can combine the 5 and the 3, so I get 3x plus 8. I would see if I could cancel anything. There's no GCFs or anything that would cancel. I can't, everything's holding hand, so I can't cancel anything. There is one invalid value, the denominator. One said 1, so there's nothing there. But the other one said x plus 1, so what would make 0 would be negative 1. All right, let's do example number 3. So I have 3 fractions this time. So on top I have 5 over, I'm going to try to factor my denominators. I'm going to make my bar a little bit longer. That would be x times x, right? Plus 3 over, well, x can't really be factored, that would just be x. Plus, my next one is 1 over 4x. There's no other numbers, but there's 4 times x. All right, then I just have to decide which one each is missing. So like the first fraction has 2 x's, but the other two only have 1. So I need to multiply both of these fractions times x so that now all of my denominators all have 2 x's, right? 2 x's, 2 x's, 2 x's. See, now all my denominators will have 2 x's. But the last fraction has a 4 in the denominator. So that means I need to multiply these, the middle one and the first one all need to get multiplied by 4, because then now all of them have a 4, right? So now all of them say x, 4 times x times x. They all have 2 x's and a 4. All right, so what we have for the first fraction would be 5 times 4 is 20 over x times 4 is just 4x squared. Plus 3 times x times 4, so I multiply 5 times 4. 3 times x times 4 is 12x over 4x squared. And my last one is just 1 times x, so it's just x over 4x squared. So they all have the same denominator now, okay, or else we would have multiplied by something wrong. So I keep that 4x squared denominator, and then in the numerators, I just combine any like terms. All right, so when you combine like terms, I can add the x's together. So I get 13x plus 20. And then I see if I can cancel anything. Like, can I cancel the 4 and the 20, make that a 5? No, because it's holding hands, right? I can't cancel the x's because it's holding hands. I would try to do like a GCF if anything could be factored out, but nothing can, so that's just my final answer. I do have one invalid value. It's the same for all of them. If you plugged in 0 into any of these original denominators right here, they would all give me 0. So I just say x can't be 0. All right, 2 more. The next example, so it says 3x over 2x plus 1. I would try to factor the denominator if I could. 2x plus 1 cannot be factored, so I'm just going to stick it in parentheses. I make my fraction a little bit bigger than normal. Over 8, or plus 8 over x minus 3 can't be factored. There's no GCF there. And then, so if there were common factors, like if I could put like the fraction over the fraction, they would like cancel. You know, I would have something I could do there, but we can't do anything here. So what we're going to do is we're just going to do like the switcheroo. Like this one's going to go over here, and then this one's going to go over on this side. So you just take the opposite denominator on that fraction. So the 2x plus 1 is going to go onto the other fraction, top and bottom. And then now they both have a 2x plus 1, but this first one's missing x minus 3. So multiply by that on the top and the bottom. Okay, so now we should notice, hopefully, that our denominators are both the same. I'm not even going to multiply them out. They both have an x minus 3, and they both have a 2x plus 1. Okay, so they're exactly the same. So I'm just going to leave that denominator as that. I'm not even going to multiply it out. I'm just going to leave it as 2x plus 1 times x minus 3. On top, I do have to do some, distributing and things. So I'm going to distribute 3x times x is 3x squared. 3x times negative 3 is negative 9x. And then this next one I have 8 times 2x is 16x. And 8 times 1 is 8. Okay, so my denominators were the same, so I just kept the denominator. The 2 green numbers came from the first fraction. The 2 orange numbers came from the second fraction. And then I'm going to combine any like terms that I can on top. So I'm just going to keep my denominator the same. I'm going to keep it factored. So there's a reason why, is because we want to check to see if we can, cancel anything. Factor and cancel at the end. So when I combine like terms on top, I get 3x squared. What is that? Plus 7x. 16x minus 9 gives me 7. And then plus 8. So what I would try to do would be to factor and cancel at the very end. Like, if possible, you try to factor and cancel. So I see that top piece. There's no GCFs. 3, 7, and 8 can't be, factored by, GCF or anything. But I could try to do a snowflake. 3 is A, and 8 is C. So I multiply 3 times 8 is 24. B is 7. And I would put 3x on each of these little guys. And then I would just see if I could factor. There are 2 numbers that multiply to 24 but add to 7. So 24 is 1 times 24, 2 times 12, 3 times 8, 4 times 6. And that's it. Do any of those add to 7? No. So it's not factorable. Okay, it can't be factored. So this would just be our final answer. You could multiply out the denominator. You would just do like a little box method and multiply it out. You can leave it factored. Like it probably just depends on the question of the test. They might multiply it back out. You could just do like a little box method and multiply it real quick, but there's two invalid values. In the first fraction, if you decide what would make 0, you would set equal to 0. Subtract 1, divide by 2, so it's -1/2. The second fraction, you set that equal to 0, and you would add 3 to both sides, so you would say x can't be equal to 3. All right, so our last example, or number 5, our next example, our last one. There's one thing I noticed that none of our other problems have had so far, and that's a minus sign. So I haven't talked about what to do yet with a minus sign. If you see a minus sign, the first thing that you should automatically do is change it to a plus and then distribute it to every piece in the numerator. So the first thing you should do is if you see a minus sign, any of your homework problems, is to change that minus sign to a plus sign and then distribute it to all of the pieces on the top. Okay, so if there was, 2 terms on top of the fraction that comes after, then you would distribute it and change the sign on both of them. This one just happened to only have one thing on the numerator, and that was 4, so I made it -4. Now I can do the problem just however I did them before. Okay, so I'm going to first try to see if I can factor the denominators, right? I already know kind of something wrong with this first denominator, how it says 3 minus x. I want to change that to say -x plus 3. And then we don't usually like to leave the negative sign. The x is negative, that's why it was written the other way. So what I'm actually going to do is factor out a -1 from that and change it to become positive x minus 3. So what that's going to do is I'm actually going to move that negative to the top as a -1 over x minus 3. So I know that seems kind of confusing. So what I did is I switched them around. Okay, I moved the -x into the front and the 3 after. I factored out a -1, right? So that was written in front of x minus 3. That changes, you divide the -x by -1, you get positive x. Divide the 3 by -1, you get -3. But since we just are dividing by a -1, I just moved the top, like 1 divided by -1, I just moved it to the top. So that's why the top's negative now. Okay, and then plus, okay, that I have on top, I'm not going to factor or do anything with that. It's only the denominators. We only factor the denominators. That was our step 1 we wrote down. To factor x squared minus 2x minus 3, I'm going to try a snowflake because it has 3 terms. There's no GCF. It's a quadratic. A times c is -3. B is -2. So I need 2 numbers that multiply to -3 but add to -2. So those 2 numbers would be -3 and 1. -3 times 1 is -3. -3 plus 1 is -2. So on the bottom I have x minus 3 times x plus 1. Okay, so do you guys see maybe why I did this whole thing earlier right here? Is because now what do both of these denominators have in common? Okay, so from there, we're going to go ahead and go to our last denominator. It says x plus 1, so I'm going to make that, oops, shouldn't have written all in the same color. I should have switched some colors. My -4 stays the same on the top, and the denominator I try to factor. X plus 1 can't be factored. There's no GCF, anything I can kind of do there. Okay, so now I look at my denominators and I see that these first 2 denominators both have an x minus 3, right? My last denominator doesn't have an x minus 3. So what I'm going to do is on the top and the bottom of the last fraction, I'm going to multiply by x minus 3. So now they all have that, right? X minus 3, x minus 3, x minus 3. They all have that. Then I noticed that these 2 fractions both have an x plus 1, but this fraction doesn't. So what I need to do is I need to multiply that first fraction by x plus 1, top and bottom, because you're really multiplying by 1, because they cancel out, right? You're multiplying by 1. So now when I look at my denominators, right? X minus 3, x minus 3, x minus 3, x plus 1, x plus 1, x plus 1. So they're all the same, right? So once our denominators are the same, we go ahead and keep that denominator. So I'm going to just make one big denominator down here. Not even going to multiply it out. I'm just going to leave it how it is, factored, in case I can cancel later. And then in the numerators, I'll try to do different colors so you guys can see which one's which. So -1 times x plus 1 is -x minus 1. And then I have just 10x plus 6. There was nothing I multiplied there, so that one just stayed the same. This one just stayed the same. And then the last one over here, I have negative 4 times x minus 3. So on the top of that one it would be negative 4x plus 12. All right, so my denominator is still the same, x minus 3 over x plus 1. Then I'm going to combine like terms in the numerator. So I have a negative x, a 10, and a negative 4x. So that would be, what, 5x? And then I have a negative 1, negative 6, and 12. 12 minus 6 is 6. 6 minus 1 is 5. So then here I would try to see if I could factor and cancel anything. So I can't like just cancel my x's or anything because they're holding hands. But on the top I notice there's a GCF. Both of these numbers have a 5. So I can factor out a GCF of 5 and I would get x plus 1. And then on the bottom I have x minus 3 times x plus 1. So after I factored out that x plus 1, I notice that they actually cancel. I don't have room at the bottom, so I'm going to write it up here. So I have 5 over x minus 3 would be my final answer. We do have some invalid values. If I look at my denominator right here, okay, before I canceled, I would just say x can't be equal to 3 and x can't be equal to negative 1 because those are the numbers. If I plug them in, I would get 0. All right, so let's get these notes into our digital notebook. So the notes part that we took, okay, notes part that we took goes on slide 12. We only had like a little bit of notes that we wrote down. And then page 19 goes on slide 13 on the left, and page 20 goes on slide 13 on the right. If you forgot to put in your table of contents, that's what the title is, okay? Add, subtract, rational expressions. And that's it. You can go do your homework. Remember, you have to have same denominator, so you got to decide what you're going to multiply the other fraction by to get them to be the same. Okay, bye.